So what we're going to do today, we're going to talk about linear inequalities in one variable. The first thing we need to talk about is the concept of a number line, which we've already briefly discussed. We'll call this a standard number line. It represents all the real numbers. It has arrows on either end because the numbers keep going and going and going in each direction. They go on forever to the right. They go on forever as you go to the left. They get smaller and smaller and smaller. They get larger and larger and larger. Now, usually, but not always, we'll center our number line at 0. And so all the positive numbers are over here on the right. And so you might have 1, 2, and 3, and so on. And they keep going and going. You can go all the way up to, you can go up to a trillion, a billion. On the left here, you might have -1, -2, -3, and then that keeps going and going and going downwards. That's the basics of a number line. You get the idea. Now, what we're going to do is we're going to talk about inequalities, excuse me. And what an inequality is, an inequality uses the following signs: the less than sign, the greater than sign, the less than or equal to sign, the greater than or equal to sign. Technically, you could also use the not equals to sign, but we're not really going to worry about that one today. And then what we're going to find out is that we might just want to graph certain inequalities. So let's try this on for size. Let's graph x greater than or equal to 2. We're literally going to shade the region on the number line that corresponds to that. And if it's greater than or equal to, if you're using the or equal to, you're going to use a nice filled in circle on the number itself. And then since we want everything greater than that as well, we're going to shade everything on the number line to the right of it. I'm going to shade everything to the right of it. closed circle on the 2 itself. Another notation you see, here we used a closed circle. Sometimes you'll see them use something called a bracket. It's a nice bracket that has 90-degree angles like this. That's another way that you can demonstrate the idea that the 2 itself is included because it's greater than or equal to 2. So that's very nice. Figure out where the number is, figure out if you're going larger or smaller than it, that is shading to the right or to the left of it. And then figure out whether you should use a closed circle on it or a bracket. And that's if you're dealing with the or equal to's. If you're dealing with a strict inequality, strictly greater than, strictly less than, you could use an open circle that's not filled in or a soft parentheses. So let's look at another example. How about x less than 1? X strictly less than 1. So here, do we include the 1 or is the x or is the 1 itself not included? It's not included. So because it has to be strictly less than 1, it can be everything up to but not quite including 1. So you can do 0.9999999, but you can't quite include the 1 itself. So one way you can do that, you use an open circle on the 1. And then since it's less than 1, we shade everything to the left of it. And of course, my shading looks bad. It's usually going to look bad when you freehand it. The nice thing is, whenever you're doing these kinds of problems on MyLabs Plus, and if it's usually going to be a multiple choice problem, it's going to say pick the correct graph. Pick the correct graph. Well, it's going to be nice and even. The shading's going to be obvious. It's going to look real pretty because it's computer generated. You know, that's not a bad way to think about it. That's not a bad way to think about it. Yeah, so that's actually, I never even thought about that. You see, this is a less than sign, so it looks like it's pointing to the left. And that's kind of it. There's one caveat to that. You have to make sure your variable is completely by itself. It can't say 3x. It can't say negative 2x plus 7. X has to be all by itself, and you want it to be on the left-hand side. Because technically, x less than 1 is the exact same thing as 1 greater than x. It's the exact same thing, but suddenly it looks like it's a greater than, but it's not. So your thinking is correct as long as you restrict yourself to having the variable by itself on the left, everything else on the right. But that is a good observation. How many of you want to hear a really, really lame joke? One that I am almost darn near ashamed to even utter. How many of you are ready? How many of you truly don't want to hear the joke? Anyone who truly doesn't want? All right, I'm going to have to tell it. I always preface with this is a bad joke. You're not supposed to laugh at it. You can laugh at it, but it's not funny. So try not to laugh at it. Whenever you're shading, whenever you're doing the shading, you want to use real thick shading as opposed to what? Real slim shading? Real slim shading? And me being slightly under the weather still, the enthusiasm behind that joke was immense. I mean, you can just hear in my voice, my completely monotone voice that lacks a lot of energy, just how much I thought of that joke. You know what's funny? If I would have presented that joke in a different way, if I would have said it was hilarious, if I would have put on my usual, pizzazz behind it, I could have maybe scrounged up a couple more laughs or a bit more emphatic laughs. So it's all about the preamble you give to a joke. That's a very common comedy technique, is to present the joke in the proper context. People will laugh at it. But that joke just wasn't very funny. One other thing to note, sometimes you'll see the open circle used. Sometimes what you'll see is a parentheses, a nice soft-ended parentheses, whenever you can't include the number itself. And the parentheses just has to go point in the same direction of the shading. And that's just another way of doing so. Open circle or parentheses corresponds to a strict less than or a strict greater than. A closed filled in circle or bracket corresponds to a less than or equal to or a greater than or equal to. So not so bad, especially when you have the x by itself. On one side, you have the inequality sign, and then you have a number. But it's much more common to see something like this. 3x minus 7 greater than 5. Now, what are you tempted to do here? What is your initial temptation? Add the 7 to both sides, then do what? By 3, yeah. Basically, your temptation here is to isolate x, right? Excellent, yeah. That's exactly what you want to do. So your temptation is to treat it like an equation. Like instead of the greater than sign there, I just had an equal sign. Your temptation is to treat it like an equation, then isolate x. That's a good temptation. There's only one slight difference to keep in mind. And I'll tell you guys that difference in just a moment. Like I said, I'm still feeling a tad under the weather. It's not COVID. Don't worry about that. But it's a good temptation to just try and solve it like it's an equation. One thing to keep in mind, if you multiply or divide both sides of the equation by a negative number, you have to flip the inequality sign. The reason is because when you multiply or divide by a negative, you're changing whether or not something is positive or negative. Thus, you're putting it into kind of a mirror universe, a mirror around the number line, around 0. So let's try solving this one. 3x minus 7 greater than 5. Exactly. So we'll do it step by step. We'll add 7 to both sides. Now, did we multiply both sides by a negative number or divide both sides by a negative number there? No, we just added a number. You can even subtract a number from both sides. You can add a negative number. That doesn't matter. It has to be multiplication or division. So what's my next step here? Yep, divide both sides by 3. Did I divide by a negative number? No. So that's going to be my answer. And that's it. The sign never had to change because I never multiplied or divided both sides by a negative number. It is just that simple. What we'll do, we'll graph this solution set here. You just need to make a number line. You put some arrows on either end. Find x equals 4. Let's say it's right there. You don't even need to put the 0 on there, technically. Will I use an open circle or a closed circle? Open circle because it's strictly greater than 4. And then shade everything to the right because it's greater than. Bada bing, bada boom. Any questions on that one? Any questions? So again, you can approach it like you were just solving an equation. Approach it like you were solving an equation. Let's try a different one. Let me try to find an interesting one. Give me one moment to find an interesting one.